Sir,
Shall we start, sir?
Yes, exactly.
Yes.
Just switch off my fan. There is little noise.
Yes. Dear participants, there is a small request. So please mute your microphones so that there shall not be any kind of disturbances in between. Well, good afternoon, all. Myself, Keshavamurthy MD, Head of the Department of Zoology of our college. At this outset, I welcome you all to the day 6 of 7-day National Faculty Development Program on Research Methodology in Social Sciences, organized by Internal Quality Assurance Cells of our college. The topic this time for today is data analysis using SPS. On this occasion, I specially welcome Dr. Nandakumar Mekoth, today's resource person on behalf of our college. It will be my privilege to welcome Dr. Bhaskar Shetty S., principal of our college and the backbone behind this program as well. I welcome all the participants who have entered into this session, who are eagerly waiting for the session to begin. I also extend my warm welcome to Dr. Rajendra, HOD of Department of Sociology and the convener of the program, Dr. Umesh Maya, Assistant Professor of Commerce, Professor Sojan KG, Coordinator, IQAC of our college, and Ms. Ramya, who is technically assisting us in this particular session. At this outset, it will be my privilege to introduce the resource person of today's session, Dr. Nandakumar Mekoth. Professor Nandakumar Mekoth is a professor of marketing and chair fellow program in management at Goa Institute of Management. He teaches marketing and research methodology and has research interests in several services and consumer behavior. Professor Mekoth holds a doctorate of the University of Calicut and has completed faculty development program of Indian Institute of Management, Ahmedabad. He has more than 30 years of postgraduate teaching experience and research experience at Goa University. His teaching area is marketing with research interest in services, marketing and consumer behavior. He had held positions like Dean Faculty of Management Studies, Head of the Department of Management Studies, Chairperson of the Board of Studies of Management Studies, Member of Academic Council, and Member of Court at Goa University. Professor Mekoth has published in many national and international highly reputed peer-reviewed journals and presented his papers in conferences which are organized by premier institutes like Indian Institute of Management and international universities in Italy and Switzerland. He has taught in University of Applied Sciences, Germany, under exchange program sponsored by DADD. He has also taught at University of Ravensburg, Germany. He has guided several PhD students and MPhil students successfully. He has been an invited resource person in several research methodology workshops and has specialized skills in research methods, including data analysis using SPSS and structural equations modeling using AMOS. With this very short introduction of Dr. Mekoth, I leave the space for Dr. Mekoth for the session to continue. Sir, can you please unmute your microphone? It's muted. We are not able
Thank
to.
you very much.
Yes, yes.
Thank
yes.
you very much. Am I audible?
Yes, sir. Yes. Absolutely fine.
I have done away with my earphone because that is not functional, I think. It is not helping me to hear.
Okay.
So I think
Anyhow, your voice is crystal clear, not a problem.
Yeah, so I can go ahead. There are 42 participants. Are we expecting more participants? Or?
Some are watching it in YouTube, sir, because we have limited the number to only 100 registrations in this app, because more than that we cannot accommodate here. So many of them will be watching it live through the YouTube as well.
Okay. So, okay, I'll start quickly. So I just want to know how many of you are beginners. Beginners means who do not know about SPSS, because the briefing given to me is to teach you SPSS and the statistical analysis using SPSS. So I'll be stressing on SPSS rather than statistics, because you already know some statistics. I have seen your program.
Sir, many of them are new to SPSS, sir.
So can I get a poll? How many of them do not know? How many of them want to know right from the beginning?
I think majority of them are not doing that one.
So can I get a poll? Can they raise hands or something like that? How many of them want right from the beginning? Can they raise hands?
Dear participants, sir, sorry for the interruption. I request all the participants to, you can just comment it on whether you are new to SPSS or whether you have already some kind of introduction to that SPSS software or whatever.
Okay, I think many are new because a lot of people are saying new. Yeah, a lot of people. So I'll start from the beginning. So I'll share my screen, then I'll start with a demo. Okay, a lot of people are new. Okay, so can I share my screen? I'm sharing my screen, okay? So if you install SPSS, you are seeing my screen, all the participants, you can unmute and say yes or no. Yeah, you may be muted, all of you may be muted.
Yes, sir, it is visible.
Yes, sir.
So there is an icon, see, this is the SPSS icon.
Can see, sir.
When you install SPSS, you will get an icon like this on your screen, So I'm just opening it up.
That sigma A, that is one, sir?
Yeah, sigma A by something.
Okay, sir.
So I'm just clicking on it, and this is the one I'm double clicking and opening it. It will be a spreadsheet like Excel. You will get, this is an IBM software, SPSS. So you will get a spreadsheet like this. It has two views. So right now you are on variable view. This is called variable view. You see here downwards, left bottom corner, there are two views, data view, variable view. You can switch between them. You can click on data view, then you can click on variable view. So right now I want to ask you, you know what is a variable, okay? If you have any doubts, you can ask me. I think you can put it in the chat. I can't manage chat when I am doing this. So you can unmute and ask me if you have any doubts. So something like your age is a variable because you can relate it, you can measure it. Age, what is your age? It may be 35, 45, 55, 25, 18. It can take many values. So it's a variable. And you can relate it with something else, maybe your self-efficacy or status or income or something like that. So every variable has a name. Every variable has a name. So I can type variables. Your age is a variable. Your gender is a variable. So I'll type here gender, for example, gender. So I have entered a variable. Now I should tell what type of variable it is. So I can put here numeric variable. It has come here, numeric. So let's assume it is numeric variable. And then width. There are eight spaces are there to type. So that's good enough. Decimals, to that you can increase and decrease here. Since it's a nominal variable, you may not need decimals. So you can increase or decrease these decimals. Suppose you have age, you can put 8.3, 10.5, all those things. So you may need decimals. Right now, you don't need decimals. So you can make this 0. Label, you can type here gender. Anything in long one, you can type here. Gender of the respondent. Gender of the respondent. Here it takes only one word. There should not be any space, etc. But here space can be there. Values, you can type, you can give a number to that. For example, male can be 1, female can be 2. So you can give values here. Value is 1 for male. You can add that here, 1 for male. You are with me, all of you? 1 for male and 2 for female. This is called coding. 2 for female. 2 for female. You can add that also. So you are given, okay. So it has come here, 1 for male and 2 for female. It has come there. So 1 is male, it is showing here. 1 is male, 2 is female. Missing values, you can write here, none of them are missing. When it misses, you can actually treat here. You can give some code to that, no missing values, discrete missing values, and all. This you can ignore right now, but you can code. Suppose you have a non-response, you can code that as 7 or something like that. Columns, 8 columns will be there. This you can increase and decrease. 7 columns, 6 columns. How many columns? This is about your data view. How many columns you need. Right aligned. Numbers will be right aligned. And text will be left aligned. Measure unknown. This is not unknown. This is called a nominal variable. Because this is gender. It is male, female. Only 2 groups are there. These kinds of variables which create groups are called nominal variables. Gender. Then you can have variables like status, or say for example your occupation. You are a teacher or you are a chartered accountant. All those things which creates group. So you can put people into groups. Males 1 group, females 1 group, chartered accountants 1 group, teachers 1 group. So those kinds of variables, or married, unmarried, marital status. So these kinds of variables are called nominal variables. Whereas variables like age, income, which can be measured on a scale like 1, 2, 3, 4, large number, with points and all. It can be 15.3 and all. So those kinds of continuous variables are called scale variables. Right now, we'll put here nominal variable. So this is an input variable. Let's think it's an input variable. There are input variables and output variables, target variables, different kinds of variables. Right now, we'll put it as input variable because we are inputting it. Is that clear? This much is clear to you?
Yes,
Hello?
sir. Yes,
So
sir.
you have defined a variable. Now, for example, you told your first variable, this may be in your questionnaire, a variable, you will ask what is your gender, and then you will give options, male, female, and or maybe third gender. So you will have three categories. So male can be 1, female can be 2, and third gender can be 3. Or right now we have created male and female. Is that okay? Gender is a variable which has two values, male and female, which is a nominal variable. It will be right aligned. It will be measured in numbers 1 and 2. So it is a numeric variable. So we have defined the variable here. We have defined the variable here. Now, if you go to data view, there it will, here it's a row. Gender is a row here. If you go to the data view, it will be a column. So it has come here already. Now here, these rows are respondents. So 1, 2, 3, 4, 5, 6, 7, 10, 11, all these are respondents. And it goes down. You can have respondents 30, 40 and all. So it can keep on going down. So here you can enter the values if you want. Like for example, the first person is a female. So you put 2 there. Second person is a male. So you put 1. Third person is a male. Fourth questionnaire is filled by a female. Fifth questionnaire is filled by a female. Sixth questionnaire is filled by a female. Next questionnaire is filled by a male. Understood now? So you can keep on entering male, female like this. 1, 1, 2, 1. Is that okay? Hello?
Okay, sir.
This much is understood. Any doubt is there?
Yeah,
Now,
yeah.
if you want, you can add another variable here. You can add another variable like age. Age or income. Age you can add. Age you can add. It's a numeric variable. So same things. Numeric 8. 2 decimal place you can give 2, or it can be reduced or increased as you want. Then I am typing here the label income. Values will not be there because you don't have to give any value to income. It is rupees, and if there is no 1 is 1 only, 2 is 2, 10 is 10. 20 is 20, 50 is 50. So you don't have to say 1 is male and 2 is female, because 1 is also rupees, 2 is also rupees, everything is rupees. So it will not be there. So you don't have to enter anything here. Missing values, none. All same. So this is right aligned. So this will be a scale variable. This will be a scale variable, input variable. So now this will appear there. If you go to data view, suppose you go to data view, age has come here, so you can enter age. Say first person is 40 years, is a female, 40 years. Second person is say 50 years, and this person is 55, 35, 30, 20, 30, 40, 50, 60. Is that okay? Now you have entered so this is how you enter data. Now you can put another variable here, income, or urban and rural, or whatever it is. Income, and the same way you can type all these things. Oh, sorry, here I have put income, this is age, income, and this is again what kind of variable it is? Nominal, ordinal, scale. What is it?
It is scale.
scale variable. So you have put scale variable here again, and you can enter income. So all these things. Question. You can keep on entering variables here, age, income. Now you can put residence. So here it is, residence. So decimal is not required, so you can reduce decimal to 0. Here also you can reduce decimal to 0, no problem. Age. And values will be what? Urban. 1 is urban and 2 is rural. 1 is urban and 2 is rural. And okay. This will be what kind of variable? This will be what kind of variable?
Nominal.
Nominal variable. So nominal variable, scale variable, these are important variables. Ordinal variable is also there. Right now, you need not worry about that. So right now, there are gender, age, income, residence. All these will appear here. Income you can add, you can enter income. First person is 40 years and he gets income of 35,000 per month. Next person gets 1 lakh. Next person gets 50,000. Next. So is that clear to you? Now you can find out the average age, etc. Suppose you want to find out the average age, then what you do? I'll just show you in advance this one. This I'll show you in advance. So this is the only way to enter data. This is the entering data, and you can also export files. You can import Excel files and all. You can enter this data in Excel and bring here. That is also possible in Excel or some other files. You can open files. See, for example, when you go here, file, open. So it will tell what kind of file it will ask. You ask data files, then it will ask what kind of file. So you can say SPSS file, Excel file is this, the Excel file. The other files are the Lotus, DBase, all these types of files can be opened here. Is that clear to you? So you can either enter the data in SPSS itself, or you can enter it in Excel or some other file, DBase or something, and bring here. Is that okay? So 50,000, say 20,000, or 2 lakh. I put 2 lakh, 90,000. Shall I move forward? Anybody wants? So how do I manage chat here? I don't know. How do I see your chat? Is it understood?
Yes, sir.
Unmute and see.
Yes, sir.
Are there microphones muted? Participants?
Hello?
No, sir, we can unmute and speak as and when we want.
Yes. Yeah.
So is there any problem? Is it understood this much?
Yes.
So you
Yes,
can put residence here. First person can be urban, rural, urban, rural, urban. Is that okay? So like that you can keep on entering data. Now
Yes.
you can analyze this. You can find out what is the average age, what is the average age of males, what is the average age of females, what is the average income of males, and you can compare them, do t-test, and all these things can be done. Is that clear to you? Number one, first point. If that is clear, we'll go to the next.
Yes, sir, clear.
Any questions? Anybody wants to ask any questions at this stage?
I have a question, sir.
Yeah, please.
In the residence, we can
Yeah.
also allot 1 or 2, like Delhi for 1, NCR for 2. we can also use this, or we only use urban or rural kind of thing?
You can use anything. You can use 10 and 20 also. You are asking whether you have to use 1 and 2 only. No?
Yes, sir.
No, you can use 10 and 20. You can use A and B. You can use anything. You are just giving a name. Nominal variable. You have nominal variables. You can give anything.
Thank you, sir.
You can give 10 and 20, 100 and 200, or 15 and 25. Anything you can use, whatever you want. Any other questions? Is it understood?
Yes, sir.
Okay. So we move ahead. So I'll open one file now and show you some analysis now. Okay. Some other things I'll show you. So I'm closing this file, or I'll minimize it and keep here. I'm opening a file called grades. So I have many files here. So there is a file called grades. See, this file has 21 variables. This is a variable view. I am in a variable view, and it has got 21 variables. These are the marks of students. If you go to data view, you will see all these variables here, and they have data. This data is the name is there, gender is there, ethnicity is there, year is there, lower up to section is there, grade point average is there, quiz 1 is there, quiz 2 is there, marks are there, total mark is there. Is that understood? And how many people are there? Let us see how many people are there. Go down. 105 students are there. These are the grades and other details of 105. This is entered just like how we entered the grades just now. This is entered the same way how we entered the data. Same way this is entered. For example, the first person's name is Belarus Alfred. Belarus Alfred is, I think it is female. 2 is male, I think. Male, or we can check it whether it is male or female. For example, you can go to variable view and you can check here ID, gender. Gender 1 is female, and 2 is male. You can check here. Is that okay? Hello. So you can check.
Yes, sir.
One is native.
Yes.
One is, so this is given here. So this is a variable definition. 21 variables are defined. And here it is. Data or 105 students are there. 105 students data are there. Is that clear? Now suppose you want to add 2 variables and create a new variable. Quiz 1 and quiz 2 you want to add. Now see what is the last variable here. Last variable is pass, fail or something. So I'm just adding one variable here. So these are some I want to add quiz 1 and quiz 2. So I make a variable called Q1, Q2. So I want to make a new variable called Q1, Q2, which is a summation of quiz 1 and quiz 2. Quiz 1 and quiz 2. So what I do is that there is an option called transform. There is an option called transform. You can compute a new variable. Are you seeing where I am? So this file is just like that. This file you can save and open, close, all that you can do just like your Word file, and close is there, save is there, save as is there. This is just like any other file, your Excel file and all. Print, you can print the file, you can print preview. Everything is there. Okay. Similarly, there is an option called transform. Are you seeing transform? So you can compute a new variable. There is something called compute new variable. Compute. So click here, compute. And what is our name of our new variable? Target variable Q1, Q2. Q1, Q2. I have created a new variable Q1, or simply Q1, Q2, Q1, Q2. And what is this variable? This is quiz 1 plus quiz 2. So I can compute it. I take quiz 1 and transfer here quiz 1 plus quiz 2. Quiz 1 plus quiz 2, and then click OK. Now see the last part of the file. Just go. It must have come there. So see the last variable. Q1, Q2. You are seeing here Q1, Q2, Q1, Q2. So this is quiz 1 plus quiz 2. 6 plus 5, 11. 10 plus 10, 20. 10 plus 7, 17. So like that you can compute new variables. Suppose you want to create quiz 3 plus 4 plus 5. Then you can create that. For example, I am going here again, transform. Compute variable. I am computing a variable which is now Q3, Q3, Q4, Q5. 3 variables I am computing. Q3, Q4, Q5. You can give any name here. I can give a new variable. I can give the name of the variable as new also. New variable, new, NEW, new. And this I am removing from here. This I am removing from here. I can reset it. There is an option to reset. I reset. So I have to type new again. New again. So that is Q3, quiz 3 plus. I can find percentages. Everything I can do here. All computations I can do. Q4 plus Q5 is equal to OK. I have done it. Where is my file? Grades.sav. So the new variable has come here. New 16, 22. It is done for all the variables. Like that you can do anything. You can calculate percentage. Quiz 1 is as percentage of total. For example, you can do quiz 1 as percentage of total. So what I can do is that I can transform the variable, transform, compute, quiz 1. So it can be 100, reset. I am resetting everything. The new variable is new 1. Or percentage I am giving, percent. Some name I am giving. So this is quiz 1 divided by total. I can do it 100 multiplied by 100 multiplied by quiz 1 divided by I can click here also, divided by total. There is something called total here. Total is there. Yeah, total is here. Total. Okay. Change existing variable. Okay. It's asking change existing variable. Okay. So that percent has come there. So we can see again. Percent I have put here. See, it has come here. It has changed the existing variable. So I can create %1, another variable. Is that clear? So you can compute a new variable. You can recode an existing variable. Suppose you want to recode this. Suppose you want to know this new. You want to make this into 3 classes or something like that. Say this variable new, you want to make into 3 classes. So let us make a new variable called class. Okay. So I am recoding into another variable. So first I should know new, what is the maximum and minimum of new. So I'll go to analyze, descriptive statistics, descriptives. So what is the last variable? I have new. So new is here. I go put it here and okay. So I got the maximum and minimum here. Maximum is 30 and minimum is 6. So I can make say 0 to 10, 10 to 20, 20 to 30. Like that I can make 3 classes of this variable. Minimum is 6, maximum is 30. You understood, no? So I can make 3 classes of this. So I can recode it. It's called recoding. It is called recoding. So what I do is that I'm going again to that variable. Again, I'm going to the file, grades. So this is the variable. I want to create a class. So I record into a different variable, transform. Record into different variable. There is an option called recode series. Recode, you are seeing recode? Hello? Recode into different variable.
Yes, sir.
Record. So I am recording which variable? Input variable is new. Input variable is new. I put it here. And output variable's name I can type here. So that can be class. I am making it into classes. Class. And change. I changed it. So new will be converted into, recorded into class now. New will be recorded into class. Old and new values. So I type here old and new values. Old value is, so I have to give a range. So range is here, 0 to lowest through value, lowest through 10, lowest through 10, lowest through 10. Lowest through 10 is 1. Lowest through 10 is 1. Lowest to 10 is 1. Then 10 point, so I have to put range value through highest, range lowest through, I put range here, range. So you put the beginning range here. So that will be 10.0001. So slightly more than 10 to 20. To 20, I record as 2, and then value through highest 20.0001 through highest is known as 3. So I recorded it into 3 categories. Up to 10, 1, 10 to 20, 2, 20 and above, 3. Is that clear to you? Hello? Up to 10. Lowest to
Yes.
10.
Yes.
Lowest to 10 is 1. 10.001 means 10 only. 10 to 20 is 2. 20.001 to highest. Till highest is 3. So I am converting it into 3 classes. Continue. Okay. So what happened? Let us see the file now. See, I converted 16 has become 2, 20 has become 3, 17 has become, 16, 22 has become 3, 24 has become 3, 20 has become 2, 27, all these values you see, it has become different values, 27, 14, so 2, 3. So new variable has come. Some ones also will be there. Some one is here, one is here, another one is here. 1, 2, 3, 1, 2, 3. Everything is changed into 1, 2, 3. So 0 to 10 is 1, 10 to 20 is 2, and above 20 is 3. So you can do these kinds of things also. This is called data manipulation. Data manipulation. Like that you can do many things. Like for example, there are some more options. You want to select only males, then those options are also there. You want to select only males. So if you want to select only males, you can go here, data. There is select cases. See these select cases. So you can go there and select cases. You can put, you want only males, no gender. So take gender. And then you can select males or females, only whatever you want. I think I have put if condition is satisfied. Select cases, data. cases, if condition is satisfied, all cases. So I can put here, for example, I can select gender, and then if condition is satisfied, if condition is, then I click on if, then it will tell me if what is the condition. So equal to male, I can put. So it has come here. If say gender is equal to male, like that I can select that. Then only it will do the analysis only for males. So that is, so you can do many things like this. So any questions till now? Any questions till now?
Sir, when you add a new variable to data view, will there be any change in the variable view?
Yeah, there will be. Those variables will be added. For example, you see that variables new, whatever we calculated, new variables have come here. Q1, Q2, new, class, all these things have come here. Any new variable added will come here. Is that okay?
Okay.
Only thing these you know have to change. For example, it is telling nominal, nominal, nominal. There are some of them are scale variables. Class is a nominal variable. So you have to change here. Nominal. And this is scale variable. This is also scale variable. Some changes you have to make, but they will come here. Any other questions?
Okay, sir. Thank you. Understood.
Anybody has any doubt, please ask. Now we are going to do more complex things.
Sir, can you please show how many males and how many females are there?
Yeah, I am coming to that. Before that, till whatever we covered till now, any doubt is there? That is my question.
Okay, sir.
If you have any doubt till now, whatever we covered, any doubt? No doubt, no. So now in nominal variable, what analysis you do? Nominal variable means gender is a nominal variable. Gender is a nominal variable. So it's a group. So in each group, how many people are there? That you can calculate. How many males, how many females. Or ethnicity you can do. How many Asians, how many Europeans, or how many Hispanic, like that you can do. So nominal variables, you will normally calculate the group number, how many in each group. That is called frequency. That is called frequency class. Frequency. So in nominal variable, you will calculate frequency of males, frequency of females. Suppose you want to know how many males are there, how many females are there. Then there is something called analyze. So let us do that. You can be anywhere. Wherever you are, you can do this. Analyze. There is something called descriptive statistics. I mean descriptive. You can make notes. This is called descriptive statistics. You are describing the variable. You are describing the sample. How we are describing? How many males and how many females. So frequencies. You can go to frequencies here. Frequencies are there. So you click on this and you select the variable from here. Gender is the variable. Gender is here. So I have selected it. If you want chart, you can ask here. Suppose you want bar chart. Suppose I want bar chart or pie chart. You can ask bar chart. Continue. And then click OK. So now frequency will come. See, frequency has come, then bar chart has come. This is an output file. Whatever you do, output will keep on coming here. Till now it was showing syntax. So this is a table. We found out maximum, minimum and all. Similarly, you can find out how many males and how many females. There are 105, of which 64 are females and 41 are males. 64 are females and 41 are males, and the percentage is given 61% and 38%. 100 total valid percentage is the same. So your question is answered. Somebody asked me this question.
Yes, sir. But you showed in the select cases option, right?
Yeah.
How it can be?
If you select, then it will do only that part. If you select only males, it will do only males analysis.
Okay, sir.
But I have not selected. I just showed you how to select. That's all. If you select that, others will be crossed. If you select females, males will be crossed. Then males will not come. I'll show you. Then you can do split file also. I'll show at the later stage. I'll show you split file also. How to split? You can split the file into male and female. Male is one part and female is one part. There's an option here. See, there's an option called data. There's an option to split file here. Split file. See. Understood now? So you can split the file here based on gender. You can split the file, organize output by groups. Then you can split by gender. You can transfer gender here. Then it will split the file and you will get two values. If you ask average, it will give average of males, average of females separately. Is that clear?
Yes, sir. Yes, sir.
So the basic analysis is frequency. So we can do one more frequency with a pie chart, for example. Suppose here a bar chart is given, males and females. Males are 61 and females are 64. I think males are 60. Females are 64 and males are 41. So bar chart is given. So similarly, you can do, for example, analyze descriptive statistics, frequency. So instead of gender, we can put together also. Ethnicity we can take, ethnicity. And chart you can ask this time pie chart. Continue. Okay, so it will give a pie chart now. Ethnicity, different ethnicities are given. Frequency. Native is 5, Asian is 20, black is 24. White is 45, Hispanic is 11, percentages are given, and pie chart is given. Is that clear? Any questions till now? Hello? No questions?
No, you can proceed, sir.
I can proceed? Okay. So next we will do something called descriptives. Suppose all variables are not nominal variable to calculate frequency. Now say marks, your total mark. Total mark is what? Total mark, you can take together also these variables, okay? You don't have to take one by one. You can take all the variables at a time also. So now, for example, suppose you want to analyze descriptive statistics. You want descriptives. There is something called descriptives. See these descriptives. Go to descriptives. Descriptive statistics. Descriptive. This is a nominal variable. So we don't take a nominal variable. We'll take scale variables. Like for example, here there is quiz 1, quiz 2. We'll take all the quizzes. All the quizzes let us take. Quiz 1, quiz 2, quiz 3, quiz 4, quiz 5. All quizzes you can take together and calculate. Okay, so you got the descriptives. So what all you got? Quiz 1. All n is 105. Minimum is 0, 0, 3, 2. Maximum is 10, 10. Average is 7.47, 7.98. So normally a continuous variable, scale variable, you will calculate mean. You will calculate mean. You will not calculate frequency. You calculate frequency for nominal variables. You calculate frequency for nominal variables. And mean and standard deviation is also there. See, standard deviation is also there. Mean and standard deviation you will calculate for. You know this, no? Mean and standard deviation. I am not explaining what it is. I assume that you know it. Mean means average. All items added divided by number of items, 105. So sigma x by n. You add all the items and divide with 105. You get the mean. You get the standard deviation by x minus x bar square and all. Square divided by n under root. You get this. The standard deviation. So mean and descriptive statistics. You can also calculate for other variables also. Analyze descriptive statistics. Descriptives. So I change this. I put some other variables. GPA I am putting. So I can put GPA now. Final and GPA. Final is one thing. And GPA, where was GPA? GPA is here. I calculate descriptives. So I get the descriptives. See, final is minimum maximum, average is 61, and GPA average is 2.7789. Any questions till now? So whenever you have a scale variable, you will calculate an average and standard deviation. Whenever you have a nominal variable, you will calculate frequency. In group, how many people are there in each group? That is the basic analysis, univariate analysis. Is that okay? Now there is one more option here, you should know that. So I'll introduce you to that. So this option is called explore. If you want any variable details, then it is better to go for explore, single variable. Don't take many variables here. You want to explore. So suppose you want to explore final, take final and put here and click. So you want to fit a curve or some probable plots you can put. Actually, you can normality plot with the test general you can ask. Normality plot with the test. Continue. I am clicking OK. Now you see. So many details have come about this. So many details have come about this. Oh, I wanted some other plot anyway. So see these details. You got mean is there. Mean is there. Descriptives. It is called descriptives. Mean is there. Trimmed mean is there. Lower bound and upper bound is there. Trimmed mean is there. Median is there. Median. Variance is there. Standard deviation is there. Minimum is there. Maximum is there. Range is there. Quartile, interquartile range is there. Skewness is there. Kurtosis is there. So all the details you get. If you go to standard error of mean is also there. Standard error of. I hope you know these things. I cannot explain now because that is not the task given to me. So I am not explaining in detail what is standard error and all. For that I will need one full class to tell you what is standard error. So right now, let us not go into that. So right now you get all the details like mean you get, median you get, trimmed mean you get, variance, standard deviation, minimum, maximum range, interquartile range, skewness, kurtosis, everything you get. Standard error. So this is called explore. So similarly, you can explore any other also. Analyze, explore, descriptive statistics, explore. Then you can, instead of final, I'll bring GPA here. Let us see GPA. GPA, statistics, plots. Some other options. So now you got this for this descriptives for GPA. See, mean is 2.7, standard error is here, trimmed mean is there, 5% trimmed mean, confidence intervals, standard deviation, variance, minimum, maximum, range, interquartile range, skewness, and kurtosis. All these details are given to you with one click about this GPA. Is that okay? Any questions?
Okay, sir.
So we go to the next one.
What is trimmed mean, sir?
Sorry. Trimmed mean means 5% you remove from each side. 5% trimmed mean. 5% of the top cases and bottom cases you remove. Then it is trimmed mean. Extreme items will be removed.
Thank you.
Hello.
Thank you, sir.
Yeah, welcome. Any questions? So we go to the next item. Now suppose you want to find out two values you want to tabulate. Two values you want to tabulate. Suppose you want to know gender-wise, gender and section, is it equally distributed or proportionally distributed? Then there is something called cross tab. You can cross two variables. So you take, so far we have been analyzing only one variable. Now we are going to take two variables. So what you do is that there is something called cross tab. See, cross tab. Here only, cross tab. So this crosses, this creates a cross tabulation, a table. It will create a table. So you can take gender. For example, gender can be the row, and column can be section. Section is, you can take anything, section. Let us see whether gender is allocated to section. All class, suppose there are 3 sections or 4 sections. Gender means some section is only females, some section is more male, some section is less male. Is it like that, or they are equally distributed? That's our question. So you can ask for statistics. This is normally done by using a chi-square. Say for example, here it is a chi-square. See, chi-square. So you can do, what you can do is that you can continue. And okay, so you got a cross tab here. This is called a cross tab. There are, how many sections are there? Sections are section 1, section 2, section 3, section 1, section 2, section 3, and female and male. Now, in section 1, there are 20 females and 13 males. In section 1, there are 20 females and 13 males, and total is 33. In section 2, there are 26 females and 13 males. In section 3, 18 females and 15 males. Total is 33. So this is how they are distributed. So this is a cross tab. Total 64 females and 41 males. This is how they are done. Now the question is whether there is a significant difference in the distribution. So are they equally distributed, or is there a bias in the distribution? The distribution is, there is some association between gender and sex. So sorry, gender and section. Suppose there is an association between section and gender, means some sections are males and some sections are females. That means section 1 is more of female and section 2 is more of male. Then there is a relationship. So whether there is a relationship between these two variables is calculated by this cross tab, and you check a statistic called chi-square, Pearson's chi-square. So it is 1.106 and the significance is 0.575. Means there is no relationship. We don't reject the null hypothesis. We retain the null hypothesis. Our null hypothesis is they are equally distributed. There is no bias. There is no relationship. There is no relationship between section and gender. Gender and section are not related. Means they are randomly allotted. Gender and section are not related. That hypothesis is retained. They are not related. Suppose this was 0.001, then they will reject the null hypothesis and say that there is a relationship between gender and section. Is that clear? Suppose here the value was, this asymptotic significance was 0.001 or 0.000 or 0.004, 0.04. Then we will reject the null hypothesis. We'll say that there is a relation between section and gender. Right now, there is no relationship between section and gender. Is that clear to you? Any questions at this stage? These are all similar things. This linear by linear, likelihood ratio, all are chi-square only, but different values. Normally, we take Pearson's chi-square. Pearson's chi-square. Any questions? Suppose this was 20. So let us check another one. Like for example, we can check gender and or section and ethnicity. We can take. We can take descriptive statistics, cross tab. Instead of gender, let us put ethnicity there. Ethnicity. And let us see whether ethnicity is some black people in one class, white people in one class. Is it put like that? So let us see that. So we click OK. Again, there is no significance. This is 0.087. See, so this is somewhat minor significance is there. 0.08 means less than 0.1. No, so 10% level it is significant. 10% level it is significant. 5% it is not significant. 10% level it is significant. But that depends. So we take different values sometimes. So right now, there is no relationship. 5% less than 5% means we will reject this null hypothesis. So we hold the null hypothesis. Any questions? So these are the sections 1, 2, 3, and ethnicities are native, Asian, black, white, Hispanic. These are the ethnicities. Any questions? So now suppose here you have crossed what kind of variables? Hello. Here you have crossed what kind of variables? Cross tab you have done. Gender is what kind of variable? Hello.
Gender is nominal.
Nominal. Section is also nominal. No? Section A, Section B, Section C. Section 1, Section 2, it's nominal variable. Section is also. So when you have two nominal variables, you will use a cross tab. When you have two or more nominal variables, when you relate, so relationship, basically you are relating variable to variable. Your hypothesis is relating variable to other variable. Relating variable to variable. One variable with another variable. Relationship is called hypothesis. So this is here hypothesis, gender and section are unrelated is your null hypothesis. Gender and section are related is your alternative hypothesis. So here you retain the null hypothesis. You don't reject the null hypothesis. Hence there is no relationship. Is that okay? So nominal variable. Now suppose one variable is nominal and one variable is scale. Say for example, marks. Mark is a scale variable. Then you check average. So for example, for that what you do is a t-test. For example, now let us see, analyze. So you want to compare means, whether males have more mark or females have more mark. So what you can do is that you can go here. So there is something called compare means. So we finished this descriptive statistics. We are coming to compare means. How do we compare? So two groups you are comparing. For that you are using independent sample t-test. You are comparing two groups. For comparing two groups, you are using independent samples t-test for comparing two groups. So you can compare males and females. So let us do that. Males and females. What you want to compare? GPA, or we can total or final or something, final. We can compare final. Whether final mark is more for females or males, or is it same between them? There is no significant difference. So grouping variable is gender. Grouping variable is gender. Gender means 2 means. So 1 and 2. So you should give here define groups. Define groups. Groups you have to say 1 is 1 and 2 is 2. So define groups. So final you have taken here. Grouping variable is gender. Define groups. Group 1 is 1. 1 means female and 2 is male. Continue and okay. So you got a t-test result here. T-test result here. So first one is for testing equality of variance. This you can ignore, not ignoring, but this is not significant. See, this is not significant because the value is 0.761. So there is equal variance. So you should look at this row. You should look at this row. Significance is 156.15. T value is, what is the T value? 1.431. T value is 1.431 and degrees of freedom, and significance is 0.156. Means you reject the null hypothesis or retain the null hypothesis? You reject or retain the null hypothesis? Retain the null hypothesis. Retain the null hypothesis. There is no difference. No difference between males and females in final marks. Final marks, see the average. Mean is 62 and 60. Difference is not much. Difference is only 2 marks. Not a significant difference. Not a significant difference. So you retain the null hypothesis. You are not rejecting the null hypothesis. Means there is no difference. Your null hypothesis is always no difference. Null means no. Null hypothesis means no difference. Null means no. No difference. No difference between males and females. You can check it for another one also. We'll check for analyze. Let us check GPA. Let us check GPA. Compare means independent sample t-test. Instead of final, let us check GPA now. GPA. GPA, what is the value? See, what is the value? There is difference. There is difference. See, the value is 0.048. The significance is 0.048. It is less than 0.5. It is less than 0.05. Less than 0.05. So you reject the null hypothesis or retain the null hypothesis?
Retain.
Reject the null.
Reject the null.
You reject the null hypothesis because there is a difference. See the difference? 2.89 and 2.59. Big difference. It's only 2, but difference is big. So the difference is significant difference is there. Females are scoring more. Females are scoring much more than males. So there is a significant difference between males and females. Here see, Levin's test of equality of variance is not significant. Means variance is equal. No difference between variance. So you should look at this row. This row. Otherwise you should look at this row. 2 rows are given here. So this is your row. This is your row. Your T is 2.004. Whenever T is about 2, it will be significant. 1.96 to 1.96 and all will be significant. Above 1.96, about 2 will be significant. About 2 will be significant, the T value. We used to compare it with table value in olden days. Now we don't have to do that. Is that clear to you? Hello?
Yes, sir.
Yeah, so t-test you learned. There are other types of t-tests. Now suppose you want to compare between quiz 1 and quiz 2. Whether quiz 1 marks are more than quiz 2 marks. Quiz 1 marks are more than quiz 2 marks, or quiz 2 marks are more than quiz. There is a difference between, is there a difference between quiz 1 and quiz 2 marks? Let us see. Analyze. Compare means, again your compare means, here you are taking paired sample. You are pairing one value, quiz 1, quiz 2, quiz 1, quiz 2, quiz 1, quiz 2, paired sample. Your pairs you are comparing. So it's called paired sample t-test. You have to give a pair here. So let us compare quiz 1 and quiz 2. Quiz 1 with quiz 2 you are comparing. Pair 2 is quiz 2 and you click OK. So you got a paired sample t-test here. The mean difference is minus 0.514. So there is no difference. Standard error significance is, there is difference. See, significant 2 T is minus 2.8. So big difference is there. See, different point, sorry, T is, the difference is 7.47. Quiz 1 is 7.47 and quiz 2 is 7.98. So the difference is almost 0.5. 0.5 difference is there. That's what is here. 0.5. And the difference is significant. The T value is 2.8 minus 2.8. Minus because Q1 minus Q2. Quiz 1 is smaller. quiz 1 minus quiz 2, you are getting a negative figure. That is why the t-value is negative. T-value is negative, minus 2.872, and it is significant. 0.005 means significant. So there is a difference between quiz 1 and quiz 2. So you reject the null hypothesis. You don't retain the null hypothesis. You reject the null hypothesis. There is a significant difference between quiz 1 average and quiz 2 average. Quiz 1 average is 7. So is it clear to you? Now suppose you want to compare this quiz 2 average with the national average. Suppose national average is 8.1. For quiz 2, national average is 8.1. Assume that for quiz 2, the national average is or 8.5. Let's assume it's 8.5. National average is 8.5, and your institution is 7.9. Then there is a t-test for that. That is called analyze. Compare means one sample t-test. Only one sample is there. There are not two samples. One sample t-test. Then you put quiz 2. Put quiz 2. And you are comparing against national average. Put your national average here, 8.5. 8.5. Is that clear to you? Put quiz 2 here, transfer quiz 2 here, and then put your national average here, 8.5, one sample t-test. Okay. So you get, there is a difference. There is a difference. Significance is 0.001, means t-value is 3.27 minus 3.27, means national average is much higher. National average is much higher. Your t-value is big and it is significant. It is significant. Mean difference is 0.5. 0.5 is the difference, and this difference is significant. Any questions till now?
Sir, can you explain why the t-value is negative and how to interpret the t-value, sir?
Negative. It is negative because you are minusing 8.5 from 7.98. 7.98 minus 8.5. Understood now?
Okay, sir.
That is why you are getting negative. If you put 8.5 minus 7, suppose you put your standard value, national average is 7.5. I can put that. I'll show you just 1 minute. So let's go there, analyze it again. Compare means one sample t-test. Suppose I put the national average as 7.5, then it will be positive. 7.5. Now the t will be positive. Look at the t value now. T is 3.03. It's positive now. Now it is 7.98 minus 7.5. So the difference is 0.48. It's a positive difference. So national average is less than your class average. Any questions? No questions. So now we have learned one thing, that you have a two nominal variables. Two nominal variable you use chi-square. One nominal variable, that is gender. One nominal variable and one scale variable, you use t-test. You compare means. Now, suppose you have both variables, scale variable, then normally what you do is a correlation. So how you do that is you analyze correlation. Say for example, analyze. There is something called correlate. Whether there is a relation between quiz 1 and quiz 2, let us see. Correlate. Bivariate. Suppose you want to know correlation between quiz 1 and total, quiz 1 and final, two variables you have taken here, quiz 1 and final, and you calculate the Pearson's correlation. Okay, so you got the correlation here. What is the correlation? Quiz 1 is here, final is here. So correlation is 0.005. 5, 3, 5, and it is significant. It is flagged. It is flagged. The significance is given here. 0, 0, 0. There is a relation between quiz 1 and final. There is a relationship between quiz 1 and final. They are correlated. The correlation is 0.535 is the correlation. Is that clear? You can do many variables at a time. You can do quiz 1, quiz 2, and quiz 3, for example. Let us put correlate by variate. Quiz 1, quiz 2. I am removing final from here. And I am putting quiz 2 and quiz 3 there. Quiz 2, quiz 3. Quiz 4 also I can put if I want. Quiz 4. It will give a matrix. It will give a correlation matrix. See, it's a correlation matrix. Quiz 1 with quiz 1 is 1. Same correlation between quiz 1 and quiz 1 is 1. Quiz 1 and quiz 2 is 673. Quiz 1 and quiz 3 is 858. Quiz 1 and quiz 4. Quiz 2 and quiz 4. Quiz 2 and all that is given here. So this is a matrix. You can see any variable. Quiz 2 is quiz 3. So this is a mirror image matrix. Mirror image. So 673 is here, 673. If you fold this in the middle, it will coordinate. It will coincide with this. 829 is here, 829 is here. 633 is here, 633 is here. So it will be coinciding. So it's a mirror image matrix. Only one side is relevant. Only one side is relevant. Is that okay? Any questions? Correlation? Any question? Hello. You know what is correlation now? Correlation is when one variable goes up, the other variable goes up, positive correlation. When one variable goes up, the other variable goes down, negative correlation. So all these are positively correlated. Positive correlation is there. Next technique, I'll just show you how to estimate. Suppose you want to estimate one variable from the other variables. Say quiz 1 to final, let us estimate. So one variable will be independent variable and another variable will be dependent variable. So or quiz 1 to quiz 2 you can estimate, or quiz 1 to final, let us estimate. So you do something called regression. Here you do something called regression, analyze, regression, linear regression, analyze, regression, linear regression. What is your dependent variable? That can be anything. You can put final there, final, and put quiz 1 here, and let us estimate. So click OK. So you are predicting final using quiz 1. So for final, you are predicting using quiz 1. With quiz 1, you are estimating final. Okay. So you did this. There is something called R square. R square is 0.286, means 28% of variance in final is due to quiz 1. Quiz 1 explains. Quiz 1 explains 28% of the, this is the square of this, 0.53. 53 into 53, you are getting this. 0.53 into 0.53, you are getting this 0.28. So this is a square, R square. This R is here, R square is here, R and R square. So this is square of this. That means 28% of the variance. Remaining 62% is due to something else. You don't know. Some other variable is causing that difference. But here, the difference due to quiz 1 is 28%. So you can estimate. So you have an equation. The equation is, should I write and show you the equation? Your constant is, so now let us see the table here, coefficient table. This shows that your regression is good. Significance is 0, 0, 0 means there is a relationship between quiz 1 and final. There is a relation between quiz 1 and final, and that's a significant relationship. Now, constant is 48.68. So your equation now is your this one. Your final is equal to 48 plus 1.7 into quiz 1. Is it difficult to understand? Should I write and show? Hello. Your final is equal to 48.68 plus 1.7 into value of quiz 1. Is that understood? If it's not understood, I can write and show you with a pen tablet. And there is a relationship. See, quiz 1 can predict this coefficient is significantly different from 0. That is what it is calculating. 0 is significantly. This shows that there is a significance. Means quiz 1 is a significant predictor of final. Dependent variable is final. Quiz 1 is a significant predictor of final. Quiz 1 has a significant relation with final. There is a significant relation. That is what this 0 shows. And its coefficient is 1.7. And you can estimate by putting 48, that is C. Y is equal to A plus BX. A is equal to 48. A is 48 and B is 1.7. X is quiz 1. You can estimate like that the value. So then quiz 1 changes by 1 unit. Final changes by 1.7 units. Is that clear? Any doubts? You must have learned regression already, you know. If you want me to write and show, I can write and show, but that will take time. Hello. Questions? Hello. Hello. You all are there?
Yes, we are here.
Yes, sir. Yes, sir.
Ask me doubts, I can explain.
Yes, sir.
Hello. If you have any doubts in this regression, you know, everybody knows regression.
Yes, sir.
So it's explained, you know it, no doubt. So I'm stopping here because I have another technique called factor analysis. If you want, I can show that quickly, but then it requires again some. Okay, I can show that also. I'll take another 15 minutes. So the regression, you can estimate like this, any other variable also. Let us, for example, let us see regression, linear. You can calculate GPA from final. Let us calculate GPA from final. So change this. Now we'll calculate final from GPA. Final from GPA. Okay. So you got again the regression is 0.248 R square. GPA is the predictor. Sorry, model summary R square GPA. 248 and ANOVA is here. Dependent variable is final. And you have the equation here. 47.08 plus 5 into GPA will give you final. 5 into GPA will give you final. Is that okay? 47 plus 5 into GPA will give you final, and it is a significant predictor. Either I can stop here or I can show you one more technique. It's 4:30. It's better to stop, I think. There are so many things. I can show you factor, cluster, and all. Good enough. This is a good initiation for you. So you can ask me questions. I can be here for another half an hour. So you tell me whether you want anything more or you want to ask questions. Hello, who else is there? Professor Rajendra is there?
Yeah.
Dear participants, if you have any doubts, clarifications, any queries, you can ask, or you can just post it on the chat box so that we will direct it to the resource person.
No questions?
Sir, there is a question.
Yeah.
A question has been raised in the chat box. How do you interfere adjusted R?
How do you interpret adjusted R square? Oh, okay. That is based on number of variables. If you take, see, the thing is that you can do multiple. I'll show you multiple regression. 1 second. Analyze. Here adjusted R square is there. R square, adjusted R square. Yeah, okay. So I'll do you. So here what we did is that we did R and R square, which is a variable here, GPA and final. We can put quiz 1 here. Then let us see what happens to adjusted R square. So difference between R square and adjusted R square is 0.007. Okay, you remember that figure. Analyze. Regression. Linear. GPA, I'm adding 1 more variable here, or 2 more variables I'll add. 2 more variables I'll add. Quiz 1 and quiz 2 I am adding. So now I'm just calculating it. So now our adjusted R square, you see. Now the difference between R square and adjusted R square increased from 0.08 to 0.2 almost, 0.02. Understood, no? 0.008 was the difference earlier. Here the difference is here the difference is 0.007, 0.007, 0.248 and 241. So the difference is 0.007. Now see the difference. Now the difference between R square and adjusted R square is 0.024 or something. 02. So something like 02, not 01 something. 01. So it has increased from 007 to 01. It has increased. Why it has increased? Because you added more variables. When you add more variables, what happens is the explanatory power increases. But by adding variable, you also add some noise. Some noise you are adding because there will be some unexplained part of that. So when you add more and more variables, you can increase the explanatory power. But sometimes you can go on adding variables without increasing slightly explanatory power, but doesn't make sense. So to adjust for the number of variables, when you add more and more variables, the adjusted R square will become smaller and smaller. The explained variance will become less because there will be some noise added. I don't know whether I explained it. Did I explain it? Did ask him whether he understood? Adjusted R square adjusts for the number of variables in multiple regression.
Okay.
Madhusudan sir? Madhusudan Sundaresan.
Yes, sir. Thank you.
Is it clear? Okay.
Yes, sir. I understood, sir.
Yes, the platform is open. The other participants can ask the question.
Any question you can ask. I went very fast, so I don't know whether you want to repeat anything. Also, you can ask anything you want, or any other questions, anything, or you did not understand anything because I went fast. It was very simple, but I think I went fast. Normally, I explain these statistics very well and then do the analysis. This was only analysis. There was no statistics. I didn't explain much of the statistics here.
And sir, thank you, sir. Sir, can you please provide any web links which you have shown SPSS calculation earlier to have a great insight about SPSS, sir?
I can refer one book to you. There is a book by Darren George. Darren, D-A-R-R-E-N.
Okay, sir.
D-A-R-R-E-N. Darren George. SPSS for Windows, step by step. SPSS for Windows. SPSS for Windows, step by step by Darren George. Darren George and Paul Mallory it is. Darren George, if you type, you will get it.
Okay, sir.
Darren George. Darren, D-A-R-R-E-N. Darren George. Web links may be there. You go to any website, SPSS tutorials, so many are there on the YouTube. Anybody can get these days. These are not any rocket science anymore. Everybody knows SPSS nowadays.
Sir, but SPSS software is not available. It is costly, I think.
Yeah, it is costly. Your institute should buy.
Individually, we cannot take it.
Yeah, it will be expensive. You ask your institute to buy. Trial versions are available. You can put a trial
versions only about 30 minutes it will run. Immediately it will go off.
Yeah, I know. There are practical difficulties.
Yeah.
Any other questions? I think we can wind up then if there are no questions, no more questions, I think. Or if you want one more technique, I can show you. But I think it's fine. You can explore on your own. Everything is available on YouTube. Sir Rajendra, should I continue or any questions are there, or should I show one more technique?
Dear participants, if no questions, we will conclude. I hope there are no questions.
Yeah, but that factorial analysis may take a lot of time. If you take up that factorial analysis, it may take a lot of time to explain. Your time may not be sufficient.
Yeah, basically in this kind of a session, only this much you can cover. Actually, I can quickly cover, but there's no point in quickly.
Yes, sir. Yes, sir.
Covering.
Yes, sir.
Okay, dear participants, we have come to the end of this session. At this outset, I would like to profusely thank Dr. Nandakumar Mekoth for a very technically sound, elaborate lecture demonstration on using SPSS software for statistical analysis. He has started it from the scratch, very scratch, how to run the software, to the use of employability of the software to find out to carry out regression analysis as well. So I hope this session was very informative. I also thank all the participants who have participated very actively in this session. The feedback form will be shortly provided to you, which should be filled and submitted. Thank you, Nanda sir, for once again, I profusely thank you for this wonderful session.
I'll put my email ID if somebody wants to contact me. 1 second.
Sure, sir. Sure. Please share it.
Asking for that.
Please share
just
it.
1 second. I'll see where is the chat. 1 second. I'll type my email ID.
Yes, sir.
there my email ID is there. mekoth@gim.ac.in.
Thanks a lot, sir. Thanks a lot.
Yeah, I can log off. Hello, I can log
Yes,
off.
sir. Yes, sir. Yes, sir. Yes, sir. Thanks a lot. Thanks a lot.